Hello, everyone. Welcome to the Bridgeton Free Public Library's live stream here tonight. We're coming from my home. I'm Glenn, and I work at the Bridgeton Library. And I just wanted to do a live stream with you guys so that we would stay in contact during this whole pandemic and the whole virus thing that's going on. So that's why I'm here at home. And tonight we're going to talk about 3D printing and the basics of it, what it costs to get started, and any questions that you may have. I will admit that I am kind of new to 3D printing. I've only had a 3D printer for about 4 months now. I have not designed anything on my own. I've only printed out things that other people have designed, but that's a great way to get started. And so I just wanted to show you some things that a 3D printer can print. You might have seen it for a couple seconds before I went live here. Let me switch my camera. Okay. And here are a few of the things that I have printed. Here, of course, is Baby Yoda. And that is a little ship, a little dog, a cat, and this was supposed to be a pig. But what happened was I ran out of material in the middle of printing it, and I decided to keep it because it was nice to show, because you can see how this is printing hollow inside, and it would have continued to print. It would have come all the way up and finished the outline of the pig, but the inside would have been hollow the whole time. So I like to keep it because of that fact that you can actually see how the printer was working on in the inside of all that. So let's start tonight with what is 3D printing, and the way to start with that would be to start with what is printing. And let's start with like an inkjet printer, something that you normally would see at the home or office. That's how 3D printing kind of got its name, but an inkjet printer would be something that would be in 2 dimensions, not 3 dimensions, as 3D printing is. So I have a little piece of paper here to kind of explain it here. So typical on a 3D, or I'm sorry, on a 2D inkjet printer, you would have a piece of paper like you have here, and the paper would do one thing. It would come into the printer and it would start to come out. So the paper would move on what is called the y-axis, and then you would have a print head that would go back and forth from left to right, and that's on the x-axis. So that's how a inkjet printer would work. Of course, it's being printed on a flat piece of paper, so it only has 2 different ways that it can go, which in sense is 2 dimensions, right? So a 3D printer uses the X and Y coordinates, but it also uses the Z axis, and that gives it height. So now, instead of it just going, the head going left and right and the paper going in and out, now it actually goes up and down. So there's your Z axis. And that's how you get 3D out of that. If you look at the Baby Yoda here, and if you just look at just about anything that you have around your house, you'll notice that you see in 3 dimensions. So you can turn an object any which way that you want to go and see what that object looks like. So of course you have depth perception that tells you how far away things are. So even in this video, you can tell that Yoda is closer to me than the box is behind him. So there are your 3 dimensions. So that's how you get 3D printing, at least the name of it and what it's talking about. So it's dealing with 3 axes, or axi, or however you want to say it, at a time, the X, Y, and the Z. And the type of printing that is the most common today is called FDM. That's Frank, David, Mary. FDM stands for Fused Deposition Modeling. So basically what that is doing, if you break that term up a little bit, you'll see that it's depositing material, it's fusing it, and it's turning that into a model. So what is the plastic that it uses? Well, 3D printers can use a variety of different types of plastic. PLA is the most common material, and that stands for polylactic acid. Now that is a biodegradable material. It has actually some properties from cornstarch in there. So it is environmentally friendly. And PLA, which is a type of filament, is always sold in the metric system in kilograms or in more than 1 kilogram. And its diameter for this particular application is 1.75 millimeters. So again, everything you do in 3D printing, for whatever reason, I guess they decided to do everything in the metric system, which is fine. And let's see what else. Okay, so another type of plastic that you can use for the 3D printing is called ABS. ABS is more difficult to print with, and it is the easiest thing that you could find that is ABS is black plumbing pipe. That is made out of ABS. And then there's another one called PETG. Sometimes it's referred to as PETG. That is the type of plastic that is used in soda bottles. And each one of them have different properties, thermal properties, and different ways that you go about in printing them. But PLA is definitely the easiest, the fastest, the most common, and the best way to get started. And of course, this is a 3D printing basics course, so I would suggest that if you're interested in doing any kind of 3D printing, that you would start off with PLA. So, what are we going to do today? Well, let me show you. We are going to get a better picture here of myself. We are going to make, right here, live on air, we're going to make a whistle. It's very small, and it goes on your keychain, but it is very loud. It's actually like a security whistle. And the reason I picked that tonight is because it's small enough of an item that we can print this out while we're here. It takes about 22 to 23 minutes to print, which is kind of fast for 3D printing. 3D printing is a very slow process. So for example, the Baby Yoda, he took about 15 hours to do, and he's not that big. He can fit between my thumb and my index finger. So he's only about 4 inches or so. And because of the detail that's in him, it took that much time. So, let's see, let's come back around the front. The ship here, that took about 3 hours, and that's small, and it's detailed. Now, there are also a lot of factors that affect the print time. A lot of it is the quality that you pick, what's called the infill, which is how much material is being put down, and if there's any voids or areas that are hollow in the model. So a lot of that is determined by the settings that you set the computer up for, the file up for on your computer to do the printing. So, I have some notes here. So we're going to go ahead and show the actual printer that we're going to be using today. The model that we're going to use is a very common model. It's been out there for a long time. It's fairly inexpensive. You can pick one up for about $250 or less. It really depends on where you get it. Now that might sound like a lot of money, but considering that you had to spend over $1,000 to get a printer not that many years ago, the prices have really come down on that. So let's go ahead and show the printer. The printer is a Creality Ender 3 Pro. I'll say it again, Creality Ender 3 Pro. It's right over here. And let me start at the top and just show what it looks like going all the way down. Over here. So this printer comes partially assembled. It's certainly not the printer that you have to get if you're looking for one, and if you already have one, that's all fine. I just wanted to go with this printer because it is the one that I own, and it is reasonable and it's very popular out there. There's lots of informational videos out there to help you out if you need extra help. So the unit consists of a control panel here, and let's try to show all that. The printer is not on yet, but this is the LCD screen that you can make all your selections from. There's a dial that you select, and then when you push in, it actually selects what you want. I'll move around over to here. This is called the bed of the printer, and this bed slides inward and outward, similar to the paper in an inkjet printer or most printers. And the nice feature about this printer is that it has a magnetic bed. So that means that this is the bed, this is the print surface. That means that you can peel this up and pull it off. And the idea behind that is that when it's finished creating your part, by pulling this off of the bed, you can flex this and it helps to release the part from the bed. And then you just put it back down again, you use it over again. Also, this bed is heated. So underneath the bed are some heating elements, and you can control how hot you want this to be. And the advantage of doing that is by heating the temperature up closer to the temperature of what the plastic is that's coming out, it helps it bond to the bed and keeps it from releasing. Because when it first starts printing, if it doesn't make good adhesion to this bed, it's all over. You can't do anything more. It's not gonna do anything for you. You're gonna have problems. The print's gonna fail. So having a warm bed helps things. Now, most of the printer is made out of what's called aluminum extrusions, and that's just metal that's been extruded into a shape. There's aluminum extrusions everywhere in life. You see them in all kinds of different things. And one way to kind of explain how an extrusion is made is if you've ever played with Play-Doh and you've ever used the I'm not sure what the actual term is, like the pumper type thing, where you load the device with Play-Doh, you slide in front of it a stencil, and then you push down the handle and it pushes the Play-Doh through the stencil. A lot of times it was in star-shaped or round-shaped, stuff like that. That's basically how aluminum extrusions are made. The actual specifics of how they prepare the metal beforehand, I'm not entirely sure, but that's kind of a quick way to explain how extrusions are made. So let's move around, and here is what I would call the business end of the machine. This is the hot end. So basically what happens is this device, and I'll try to show it later. I don't know if I can get under there to see that real well. I might be able to show it to you later. But there is a little nozzle down here that gets extremely hot. And again, temperatures are measured in Celsius, not Fahrenheit. And that is where the plastic comes out of to start forming your part. So this gets very hot. There's some fans here to cool it and keep the temperature consistent to what you set it to be. Let's see. The dimensions of the build plate, again, are in metric. And I believe on this model, the build is 220 millimeters by 220 millimeters by 250 millimeters in the z-axis upwards. Coming around, the control for all the axes are done with what's called a stepper motor. And there's 4 stepper motors on here. One for the X, the Y, and the Z. And then there's a 4th one that is right under here, and that's what's called the extruder. And the extruder actually grabs the filament, which is what is right here. This is orange filament, orange PLA, and it grabs it and forces it through this white tube all the way around and goes into that hot head, the hot end head. And these are just some of the wires for heating, and they're in a sheath right there. So, coming around to the back, another stepper motor. And each one of these stepper motors, for the most part, are connected with a belt and a gear. And so when they turn, you'll see it moves the bed back and forth. And here's the wiring for heating the bed. This comes out through the back. Now, what exactly is a stepper motor that you're probably asking? Stepper motor is different than a normal motor in the fact that it takes steps every time it's told to move. So, you can tell it to move a couple degrees at a time, and it will be precise in the amount that it moves. So meaning if a shaft has 360 degrees all the way around, and it can move a couple degrees or a fraction of a degree, that's what a stepper motor does. It'll do that. And hi, Jason. Hope you're doing well. Thanks for chatting. We have one of our patrons chatting. So the stepper motors are basically the whole heart of everything, because they're telling each dimension to move it to a precise location. Now, for the z-axis, that's the stepper motor here, that is actually connected with a coupler and then a threaded rod that goes through to like a bushing here. And what's different about the z-axis is it will only travel one time in the z direction during any print. Your x and your y coordinates, they'll move back and forth all the time. But the z, which is the height, will start at the bottom and move up, and it'll only do it one time for that print. So the z-axis does the least amount of work in everything that's being done. The PLA filament, the plastic, think of it as kind of like a weed trimmer line, but it's stiffer and more brittle than that. So that's kind of the closest way that you can kind of describe it. Now, the spool, which is on top, basically just sits on top of the printer and feeds the extruder. Now, the extruder actually pulls this. So if you look real close over here, there are like two pinch rollers that have a spring here. Let's see if I can move over a little bit. They have a spring there, and that spring puts pressure on these. Here we go. There's a better view. Puts pressure, and you can see how it's gripping the orange filament right there. So it's going to pull that in and push it down that tube all the way down to the hot end. And it knows exactly how much to push in at exactly the right time. Now, it also extracts too. So think if you've ever used a hot melt glue gun or a caulking gun, and you put down the glue or you put down the caulk, you let go of the trigger, and then more caulk or more glue keeps coming out. Well, that's because there's pressure behind it from the grip that you were squeezing, and you didn't really want that extra to come out. So same thing with 3D printing. A lot of times you don't want extra plastic to come out of the end all the time. So it will actually pull the filament back out a little bit until it needs it again, and then it'll push it back in again. So, and this all is done by the computer system, which is just a circuit board that's mounted inside this box right here, and that controls everything. It controls the stepper motors. It controls telling the hot end and the bed how to keep their temperature. And basically the display over here that I had showed you a little bit earlier basically just allows you to access all those controls. So it's really just an LCD screen with a selector knob on it. All the heart of what needs to be done to keep the printer running is actually contained in this small box that's part of the printer. So one other thing that I want to let you know is that this printer does not come with this item right here. From about right here all the way out, basically it's a filament guide. So here's the neat thing. This printer created a part for itself, which is kind of neat. Now this is just an add-on or an upgrade that some people do. And also the spool holder itself, which I think I can take it off for you. Okay, that is an upgrade also. It doesn't come looking like that. I'll show you what it looks like in a minute. But that is a new printed part, and you'll see on the left and right hand part of your screen the silver areas. Those are ball bearings. And this rolls a lot easier and better than it used to with the stock spool holder. And speaking of rollers and ball bearings, you'll notice that here on this axis, there's rollers on top of ball bearings that roll on top of this aluminum extrusion. There's also one on the bottom that holds it. So that keeps it from being able to go up or down or move in any way other than just left and right. So you can see how it moves left and right. If you're somebody who likes to ride on roller coasters, this is kind of the same type of design. There's rollers that are on top of the track and usually on the bottom of the track that hold your car onto the roller coaster track. So it's kind of similar to that in the type of design that it is. And over here, same thing. Roller, roller. And then there's another one down here. So that keeps everything nice and tight. And you do have to adjust that when you build the unit. Like I said, it is a kit. Half of it is assembled, the other half you have to do yourself. It took me about 2 hours. It's not that bad. It's not that difficult to use. Depending on your skill level, you know, it might take you less or more. I had a hard time judging how long it took me to do it because I was doing some filming of me putting it together, so that increased the time that I was spending on it. And finally, let me just continue on. Finally, the power supply, that's what's right back here. And this is where it plugs in, over here. So this delivers all the power to the circuit board and the motors and everything like that. And because these are kits that are cheaper than most, some of the more professional models or the models that you might find in schools or educational facilities will look a lot prettier than this one does. They might come in a square enclosure. You might get better support, and you probably are going to spend a lot more money. A lot of times you can spend up to $2,000 on one of those type of printers. So at $250 or less for the Ender 3 Pro, I think that's very reasonable. So we'll go ahead and turn it on real quick. And the power button is right here. Okay, so here's the screen that you get. And you'll see right here, that is your hot end temperature and your bed temperature. This is what you have it set to at the top, and the bottom numbers are what it currently is. And again, this is all done in Celsius, not Fahrenheit. Below that, you'll see it going from a question mark to an X, a question mark to a Y, and a question mark to a Z. And that's basically showing you the position that the stepper motors are in currently. This 00 clock is telling you how long the print's been running for, and this is the percentage completed. This is an icon of a fan for the power supply to tell you when it's running and when it's not running. And then this other 100% shows the percentage that the fans that are right here are running at. And again, it cools the high end, keeps the temperature where it needs to be. It also cools the plastic a little bit as it's coming out of the nozzle as soon as it hits where it needs to go, so it starts to solidify and fuse to the layer that's below it. So, how do you print? Well, this printer has two ways that you can print. I'll try to get closer here, but it's hard to see. It's kind of dark. It takes a micro SD card, or you can plug in a USB cable to it and print directly from a computer. So what can you print? Well, there's millions and thousands probably, or millions, who knows, of designs that are already out there on the internet that you can download, most likely for free. And you can print them out. A lot of times you just look for things that you're interested in and things that you would like to print out. So there is a website that a lot of stuff is on. It's called Thingiverse. And that's where most of the stuff that I have printed has come from. Now, on any site, for the most part, that you find a item that you would like to print out, it's not in the form that you need it to be in to go directly to the 3D printer. It's usually in what's called a STL file, which is for stereolithography. It could be in other extensions, but for a 3D printer to be able to print, it needs to be in a format which is called Gcode. And Gcode basically takes the object that has already been created and it slices it. So it slices it down into layers. So for instance, let me go back to the Yoda. When it takes a look at an object, okay, the software will start at the bottom and it will actually slice the object up in its software so it knows exactly what is on each layer. So for instance, this Yoda was printed at pretty much the best quality that the printer can do. And you can adjust the layer height that you want it to be. So the smaller the layer height, the better the quality is going to be of the print, right? So I believe that this Yoda has 450 layers. So it sliced the model up into 450 layers to get all the detail that it needed. And those layers are what become the Gcode. And the Gcode is what the printer needs to know on how to make it. So basically, it just wants to know what's on layer 1 so it can put the plastic down on layer 1. Then it moves up to layer 2, puts the plastic down on layer 2. Plastic 3, layer 3. Back and forth. So the more detailed it is, and depending on if it's hollow or semi-solid, that depends on how much material is going to be used. So let me just go over to here. Okay, now there are a few different types of software out there that can do the layering or the slicing for the Gcode. One of the most popular ones is called Cura, that's C-U-R-A. It's from a company called Ultimaker, and it's free. You can download it. And here's where all the settings are done. So somebody would design this boat that we have looking right here. And here it is. They would design it in design software, which we'll get into a little bit later. They would export it as an STL file. Then you would import it into your slicing software, and in this case it's Cura. And here's where you can make all your changes. What do I mean by changes? I don't know if you can read everything there or not, but you can pick your quality, and that's basically saying what the layer height is. There are more settings than I could actually go over with you tonight, but one of the important ones is the layer height, and another one would be the temperature. So you can set the temperature of the bed and the temperature of the nozzle here in this software. So it's not actually done right on the machine. You set it here of how you want it to be done, and then you export the model in the Gcode, and it's ready to go. So then when you go to print that on your printer, it knows what temperature you want everything to be. It knows what layer height you want it to be. And again, everything's done in the metric system. So good quality for this printer would be 0.12 of a millimeter of a layer height. And that's considered what they have here as super quality. As far as the bed temperature and the hot end temperature, I usually run about 60 degrees on the bed. So the bed over here would be set to about 60 degrees. And then the actual hot end, I usually set to about 210 degrees Celsius. It's both on Celsius. So I think 60 degrees Celsius for the bed is about 120 degrees Fahrenheit, I think, somewhere in that neighborhood. And 210 degrees Celsius, I think, is 400 and some degrees Fahrenheit. So it's pretty hot on the end of that. You can burn yourself if you do touch the hot end. We'll try to get a little bit of a better close-up of it once we start printing. So let me just come back to the software again real quick. I know this isn't the best quality filming right off of my laptop, but you'll see I've actually run this through the slicer, and this is that boat that I showed you, and it estimates 3 hours and 24 minutes and what is it, 13 grams of filament, or 4.22 meters in length of what it's going to take to do it. Now, they're just estimates. It's not always, right on the money. It just gives you an idea of it. And again, let me grab the boat. And of course, you can see the boat fits right in my hand, and you're looking at 3 hours and 24 minutes to make that. Now, this is kind of complex. It's got some compound curves on it. It actually has, you might be able to see, it actually has a steering wheel, like a captain's wheel in there for the boat. So it has some detail on it. And it's a good model that you can use to test your printer to see how well it's working. So that's that. And so I've never hooked my laptop up to the printer. I've always used the software, exported it into the Gcode, and they give you a little USB adapter that you can put a micro USB SD card into, and then you can plug it right into your USB port, copy it onto there, and then you just plug it back into the printer. Let's see here. I just want to check to see if there's anything I'm missing. Okay, all right. So let's go ahead and do our print. And let me show it to you again. This is what we're going to print out. Hold on. This is the whistle that we're going to print. And it's meant to go right on your keychain. Like that. It's very small, and it works. I'll show you. I'll let you listen to it real quick. So, kind of neat. And we're going to have a special offer at the end of this training, this live stream. So if you want to stick around, we'll talk about that at the very end. So we're going to do one of these whistles live right here, right now. I'm going to come back to the screen. And here's what I'd like to do. So to start on this printer, you would press in on the dial, and that gives you different options that you can do. And we're going to go to Prepare. And we're going to go to Auto Home. And what that's going to do is that's going to take the bed and the print head, and basically, actually it's almost auto homed right now. I'm going to move it a little bit. It will put everything right about here, which is basically the 0, 0, 0 point for X, Y, and Z, just so that the printer knows where it is, where the head is and everything else. So I'm going to go ahead and go back to Prepare and do Auto Home. Okay, so now I have it at the home position. I'm going to come back over here. And the first step that I like to do is go back to Prepare. And we're going to go to and select Preheat PLA. So what that's going to do is that's going to bring the temperature of the bed and the nozzle, the hot end, to something close to what I'm looking for as far as printing. So if I click on that and then I just say Preheat PLA, it will do both the bed and the end at the same time. So I'll hit enter on that. And if you can see there, now it's set the end at 185 degrees and the bed at 45 degrees. And you'll see the temperatures going up on both of those. And when they both of the lower numbers reach the upper numbers, it will be ready. Now, when I say to print the whistle, I have the end set at 210 degrees and the bed set at 60. So it will then start to increase it to what I asked it to be before it goes ahead and prints the beginning of the whistle. So go, starting to get closer to the temperatures. Now, if there's any questions, if you want to ask them in the chat, that's fine. I'll answer them the best that I can. Again, I just want to let you know that I've only been doing this for about 4 months, and I do expect to learn some software to do some of my own designs in the future, but it's been just so fun looking at designs that are already out there and just printing them off. For example, we were looking in the stores for a puzzle tray for sorting puzzle pieces, and you can buy these, and we couldn't find them anywhere. So I looked online, found that somebody had designed one, downloaded it, and printed it out myself. So I didn't have to go out and buy one. Now, the price and the time that it took to do these, whether or not you consider it worth it or not, PLA material is not that expensive. The 1 kilogram, which is about 2.2 pounds of material, you can get anywhere between $15 and $20, maybe $25, $22 at the highest end. Depends on the quality that you get. And it is more about the time. I think this one tray took close to 12 hours to make. So we made like 3 or 4 of them in different colors, and they do stack on top of each other. So it's kind of neat. There's lots of different things out there. Okay. So you will see now that we basically have the set temperatures at the top and the actual temperatures at the bottom are matching each other. So now this is up to temperature, and I can put my hand on the bed and it feels warm. Like it's not burning my hand or anything like that, but it is warm to the touch. So we'll go back into the menu system. And again, you'll see that the X, Y, and Z that are flashing, they're all set to 0 right now. So it's all at the home position. So I'll click. And now I'm going to say I want to print from the memory card. And on here are a lot of different items that I have put on the card myself and printed. So it lists them all in the order that you added them. So this is the one that we want to do, the Creality Ender 3 whistle .Gcode. Remember I told you everything has to be in Gcode. So I'm like, whoop, I didn't pick that fast enough. Okay, I want to say that. So you will see that now the bed set temperature, which is over to the right, is set at 60, and the actual temperature is 46, so it's going to start to raise that to 60 because that's what I requested the print to be at when I used the slicing software, which in my case is called Cura. And I told it in there when I originally did the slicing that I wanted the bed temperature to be at 60 degrees Celsius. And then once it gets up to there, it's going to most likely go ahead and raise the hot end temperature to 210 degrees. Okay, you'll see it just changed to 210 now. That was the set temperature that we told it we wanted to be at, and it's raising to 188 degrees, 190 now. And as soon as that gets up to 210, it will start to do the print. Now, what it will do is it will lay down a little bit of the filament on the left-hand side here on the bed, just to kind of prime it. Think of it as kind of like if you have a ballpoint pen that you haven't used in a while. Usually you take a scrap piece of paper and kind of run it on there just to get the ink flowing. Well, that's kind of what it's doing here when it gets ready to start. So it wants to lay a little bit of the plastic down that it's going to throw away and not use, and then it will go more to the center of the bed and start to print the whistle. Okay, it has started. And you'll see there's that orange filament right there. It's just one layer, or basically two layers. Trying to get a little bit closer for you. Okay, start to see a little bit of the whistle there. Because it's such a small design, this head covers most of it most of the time. If I did something that was taller, you would definitely see a lot more of what the print head is doing, but that would take a long time to do on this live stream. And I was just trying to do this for time. And you'll see that little hole there or circle where there's no material. That is the area where you thread your keychain through. So it's purposely leaving that plastic out so it'll create that hole. Let's see if I can come around a little bit on this side. There are a lot of shadows, I apologize. And while it's doing that, let me just go back quick to the screen so I can show you real quick. As you'll see, now you're getting some values for the X and Y, and they'll keep changing because the bed and the head are both moving, but the Z, for the most part, will move but then hold tight to what layer it's on. So basically it's now 0.6 of a millimeter, so it's a little over half a millimeter off of the bed. So that's where the head is about 0.6 off of the bed. And you'll see that we're about 9% completed. And that took about 5 minutes. Try to get a quick view of the extruder. It's pulling the plastic in. It's hard to tell, but it is moving. Sometimes it moves very, very slowly. Sometimes you can see it from the side a little bit. Yeah, you see it extracted the plastic a little bit, pulled it back out, and then it's going to bring it back in. And they're very precise, the stepper motors. They move it just enough that it needs to do what it needs to do. So, it's going to come in here. Again, like I had mentioned earlier, these aren't the prettiest looking things as far as printers are concerned, but for the price and the fact that they're basically just a workhorse that continually doing the same motion over and over again for the most part, you know, I think they look fine for what they're designed to do. The prettier models, so to speak, come at a higher price. This is basically just like a bare bones type of printer, but does the job and does it quite well. Of course, you can see that bed going in and out, in and out, in and out. And one other thing that I failed to mention that is very critical, and that is that bed has to be perfectly level before you start using it. And there's these wheels on all four corners that you adjust to get the bed level, and that is, there's a couple different methods to do it, but if you do it by hand, usually you put a piece of paper between the bed and the bottom of the nozzle, and then you tighten up the bed so that it just has some friction on that piece of paper. It is tricky to do. That's probably the hardest part of building and getting the printer ready. It's not something I would go into today because I wanted to make sure that the bed was the way it needed to be to print this part out correctly. So maybe in the future something like that could be shown in a more advanced class. try to get the nozzle for you a little bit better. Too hard to see in there. You might be able to see the nozzle. It's just a brass nozzle that the molten plastic comes out of. And again, that does it layer by layer. So on the Baby Yoda that I had showed you, it has a 0.12, so the layer height is 0.12, so it's a little bit over 1/10 of a millimeter in height, and that is small. And it continues to do it over and over again by layer until it goes from the bottom all the way up to the top, and it finishes the design. And because there are so many layers, and because of some of the other settings of what's called the infill, which is how much plastic is being put in, determines how long it takes to do a print. So anything that's usually worthwhile, as far as complex and of a fairly large size, is going to take a lot of times 10 hours or more to make. And again, if you have any questions, you can ask those in chat, and I'll try to answer them the best I can. If you've never thought about 3D printing, it's something to think about. I put it off for a long time because I just didn't think I wanted to get involved in what I thought were the headaches associated with it. And I found out that it was not nearly as bad as I thought it was going to be. And it's quite fun to see the creations come to life that you can find. Again, Thingiverse on the internet is a good place to look, and sometimes there'll be multiple designs of the same thing. Let's see. I printed another whistle out, which is much bigger and took a lot longer. It's actually kind of funny looking, but you can kind of hold it like this and whistle, like if you're at a sports game or a referee or something like that. I don't know, but I thought it was kind of fun. And it's all hollow inside, and the air goes around and makes the sound of the whistle. Let's see where we're at. Okay, so we're about 41% complete, and it's been running for about 13 minutes. And you'll see that the power supply fan is currently running, and the other fans are running. And it might be hard to hear it on camera, but when you're here in person, you can hear every time this power supply fan over here turns on and off to cool it. So again, that filament is being pushed down the center of that white tube by the extruder motor, and it goes down into the hot end, is melted, and is pushed out the end, and is fused to the layer below it. If it's the first layer, it grips onto this removable build surface, which is magnetic. And if you're interested, it's the Creality Ender 3 Pro, a very popular beginner 3D printer. I'll try to get at another angle here so you can see better. Now you can see how small this whistle is and how much time it's taking to create it. Now there is another type. Actually, there's a few other types, but I believe there is another type that is a resin-based printing. And instead of using a solid filament like we're using right now, it uses a liquid resin. And the part is actually cured by, I believe, an ultraviolet light that solidifies the resin into the shape of what you're making. One of the advantages of that is you can get a very detailed model that is very smooth and looks really great. The downside of it is there are some fumes involved, and it's a mess to clean up between each print, or when you're done for the day. So there are other types of printing. Of course, I mentioned this is called FDM, as in Frank David Mary, for fused deposition modeling. And that is what a filament type printer uses. And again, just think the filament kind of reminds you of trimmer line for a trimmer for your lawn, but it is stiffer and more brittle. And of course, it's made out of what's called PLA, and I'll bring you back over here. Here's a box of it, which stands for polylactic acid, which is the type of plastic. And here's a roll that I did open once before, and this is white in color. Again, it comes in a 1 kilogram container, spool, and it lasts a long time. You do get a lot out of it, depending on what you're doing. Now, there are people that build gigantic items, such as like helmets and things like that, out of multiple parts. Especially if it can't all fit on their build plate at one time, they can make it into sections that they glue together. If you're making something that big, you can go through filament pretty fast. But again, it's not that expensive for the fun that you get. Usually you can get a roll for about $20. Let's check again right here where we're at. 78% finished. It's been 19 minutes. You see here, this is I probably mentioned it earlier, but this is the belt right here. I'm just going to touch it a little bit. I don't want to touch it too much. This is the belt that the stepper motor is driving that pulls this bed back and forth. And there's another belt up here, and you can see that moving back and forth. And that belt goes all the way around to this stepper motor right here, and there's a pulley with a geared tooth on it, and that grips the belt. The belt has teeth on the bottom of it. You can't really see it, but that helps grip around that pulley that slides it back and forth, so there's no slippage at all. you're starting to see that that whistle now has some height to it. And right now, the nozzle is 5.52 millimeters off of the bed. Okay, we're now at 93%, 94% completed, and about 22 minutes so far. Now when this is completed, the bed will come all the way out, and you'll see that it is done because the print head will stop moving. You can see that the spool sometimes moves. Now, this isn't using a whole lot of material, so you can see the filament move just a little bit there. There you go, you can see there it goes, it's finished. So the head goes all the way over, and the front of the bed comes all the way out to show you the part. Let's see if I can show you a good overhead shot of it. So of course you've got the hole here for the air to come out, and the hole right here for it to go onto your keychain. And if you look at my finger, it's very short. And here are some more of the information. So 23 minutes is how long it took to print. And see, you'll see the temperature's now starting to cool down because basically the machine is finished, so it'll start to shut down on its own. What I like to do is I like to let it cool off before I try to peel this off, because of the bed being warm, that helps adhere the plastic to it. And when it gets cooler, it becomes more fragile and more brittle, and it allows it to pop off or pull off of this bed a lot easier. I will pull this off though right now, because this is that test strip that it does just to kind of prime the head with the plastic. So you'll see it's not meant to really adhere real well. It just kind of pulls right off, and that's trash. So I will go ahead and pull this off of the bed, the actual magnetic part, the build surface. So we can do that now. So I'll just peel this off, and you'll see now that it's stuck to it. I'm holding it vertically in the air, and it'll stay on there until I try to remove it. So let me stand my phone up. And I'll sit down and I'll put this here on the front. Now this is really warm to the touch. I would say if it was a little bit hotter, it would actually start to burn me a little bit. But it's cooling down fast now that I removed it from the actual bed. And this is the heated part here where my left hand is. So that's cooling down in temperature. And because I removed this from that surface, this is cooling down even faster. Because now I just have air around it. And here's the back side of it. And of course, this can be used over and over again for different models that you would like to print out. So here we go. So sometimes it's easier to start from a certain side, and you can bend this a little bit, and you'll see that this starts to come off. I try not to force it too much because you can ruin this magnetic surface if you pull too hard. Oh, sorry about that. I hit a button. Okay. Still a little warm. There you go. If you bend it, you can kind of pull it off. Oh, there it goes. Snapped off. So there you go. There it is. So there's not much to it, and that took 23 minutes. So you can see how it's hollowed down the center to this point for the air to come out, and the hole for it to go around your key ring. There you have it. Of course, you could print this in any color that you want. And if I wanted to print a lot of these at the same time, I could. And I would just do that in the Cura software. Once I brought this item in here, I would just copy it multiple times. And it would only allow me to put as many on the bed that the bed has room for. But you could do them a lot at one time. Now, that doesn't mean it gets done at the same amount of time. Now the time has been increased. Is it proportional? Well, it depends. But it's definitely not going to be 23 minutes to do more than one of these. It's going to be more than that. Because it still has to go through and lay down all these layers on every one of the whistles that you would be making. So you probably could make, I would say easily 30 of these at one time because they're so small. So I will just go ahead and I'll bring it around to my side and I'll just check to see if it works. Yes, it does. So I'll show you what we have right here. There we go. Show that in the camera. Over there. Again, I'll check it out. This is a good whistle if you're in trouble or whatever, or if it's just something that is fun to play with. Now, this is small and it would pose a choking hazard to children, so keep that in mind if you were to print one of these. But that basically does it if there aren't any questions for tonight. As far as the special offer is concerned, when we reopen the Bridgeton Public Library, which we do not know when that will be as of the filming of this, we will give you one of these whistles for free if you stop in and ask for one. Now, this will be just during supplies last, but I would say that I can guarantee that the first 30 people that ask for it will get one. And again, you would have to come in the Bridgeton Public Library at 150 East Commerce Street in Bridgeton, New Jersey. And you would have to stop in there after we reopen from this pandemic. Please check out bridgetonlibrary.org for more information. If you would like to come come and stop in and pick up one of your whistles for free. And also, we would love to see you back in there for our normal library functions as far as things that we usually do, which is story time, and we have Zoobrary and a lot of teen events and things like that. You can always check out what we're doing, but as of right now, we are closed as of May 7th, 2020, and we do not know when we will reopen. But again, we will be reopening at some point in time. And check out bridgetonlibrary.org for more information on that. And we just want to thank everybody who watched today. If you have any questions, you can leave them later in the comment section, and we'll try to answer them for you. I hope this was informative for you as far as seeing how a 3D printer worked. Maybe you're interested in getting one. Maybe you already have one, but you're a little nervous or afraid to start using it. Whatever, but it is something that's kind of interesting and fun, even if you're not into technology in that, because of the fact that you can print a lot of different things that are useful around the house. I did print a screwdriver holder for a pegboard that I'm using right now out of my garage. So you can get some useful things for that. So again, stay safe, and we will see you soon in the future. And I think that's it. Thanks for tuning in for 3D Printing Basics here from the Bridgeton Free Public Library. We'll see you again sometime soon.